So hello everyone, today we'll be giving the Leetcode contest. So let's read the first question. The very first one, you're given an integer n and a digit x. A number is considered valid if it contains at least one occurrence of digit x and does not start with digit x. Return true if n is valid, otherwise return false. Fine. So what I'm gonna do is, first thing, convert this number to string. String is equal to string of n. Now I can iterate over the string and just do. I would start iterating from 1 because the first letter shouldn't be x, or else wait. It contains at least one occurrence of digit x and it does not start with. So if it starts with x, if it just starts with x, I can just do return false. S of 0 equal to x. I need to convert this to character. If this is it, so I would return false. Otherwise, for int I equal to 0, I less than n, I plus plus. If s of I equal to x minus this, just return true. Otherwise, return false. Let's see if this works. What did we do? N is not declared, I guess. Yeah. Today my keyboard feels slow. Like my typing feels slow. Okay, we are reusing this variable. Let's name it m. Done. Okay, so x equal to 0, output must be true, but it's false. Wait, I guess this should be to string n. Why did we do a minus here? It should be x plus, and if this is x plus 0, then we are supposed to return true. True, false, false, I guess, yeah, false. Submit. Fine. You are given a bitonic array nums of length and split the array into two parts. Ascending part from 0 to the peak element inclusive. Descending part from the peak element to the index inclusive. So peak element would be inclusive in both of them, isn't it? So I guess we should locate the peak index first. So what can we do? First, let's do a hash define as size. Okay, int n equal to nums dot sz. Peak index, initially let us assume it at 0th index. I less than n, I plus plus. If it's both left and right, then it's a peak index. Okay, after finding the peak index, return 0 if the sum of ascending part is greater, 1 if the sum of descending part is greater, -1 if both are equal. So we need to calculate the sum. So that means let's calculate the ascending sum first and also the descending sum. Okay, till the peak index it would be ascending sum. So ASC plus equal to nums of I, and after the peak index, from the peak index, I less than or I less than n, this would be the descending sum. Okay, ascending sum and descending sum. If ascending sum is greater than the descending sum, return 0. Okay, we can simply write if statements only. Descending sum is greater than ascending sum, then return 1, otherwise return a -1. So it should be working. Okay. 1, 0, -1. Done. Did get accepted? Yeah. So we have 2 hard problems today. Wait, what are the points? One is a 6-pointer, other one is also a 6-pointer. Fine. Yeah. So now let's read the question. You are given an undirected graph with n nodes labeled from 0 to n minus 1. Node I has a value of nums of I. Node I has a value of nums of I. N nodes labeled from 0 to n minus 1. Ith node has nums of I value, which is either 0 or 1. The edges of the graph are given by a 2D array edges, where edges of I is equal to ui vi represents the edge between the node ui and node vi. For the non-empty subsets of nodes in the graph, we consider the induced subgraph. What a terminology! Induced subgraph of S generated as follows. We keep only the nodes in S. For a non-empty subset S of nodes in the subgraph, we consider the induced subgraph of S generated as follows. We keep only the nodes in S, we keep only the edges whose 2 endpoints are both in S. Okay, return an integer representing the number of non-empty subsets of S, subsets S of nodes in the graph such that induced subgraph is connected, of S is connected. The sum of node values in S is even. Okay, so this would typically involve iterating through subsets, right? If n is small, what are the constraints? So indeed n is kind of small. Yeah, n is small, but the optimal version would be maybe something like a tree dp or something. So for a general graph, with a small n. Okay, it's too small. Like 13 is fine. Can we use some sort of a bit mask approach for this? Since n is very small, right? We can. Actually, this table clearly shows you an idea of bit masks. Isn't it? Isn't it? So what if we do some sort of a bit mask approach for this? So let's get started with the bit mask approach. Vector, and let's make an adjacency list first. ADJ of edge of 0 dot push. Let's set a hash define because we'll be using this pushback multiple times and it's a long spelling. PD pushback. Fine. Dot PB. What are you pushing back? Edge of 1. ADJ of edge of 1 dot pushback. Edge of 0. Fine. There would be a counter, initially 0. And what's the idea? We are iterating through non-empty subsets using a bit mask. So if I just do int I equal to 1 because it's non-empty, because we have constraints related to sum. Okay, so first node, let's take -1, set bits equal to 0. So the basic idea is whenever it's something related to this accounting problem or something else, you need some sort of a computation which returns a Boolean value. And the constraints are small. Most importantly, you are supposed to use a bit mask approach. If it's a set bit, sum plus equal to nums of j and set bits plus plus. First node equal to -1, first node equal to j. Now what were we asked? The sum should be even. So we will write a simple check. If sum is even, then continue. Are we in the right loop? Yes, we are. Yeah, continue. Otherwise, okay, we need to check if subset is connected. How can we do this? We can do some sort of a graph traversal, right? So let's do a BFS, a simple BFS. So let's take a Q int Q dot push. This is the reason we were storing the first node, so that we get a basic start. Visited count is equal to 0. Visited mask is equal to 1. Shift first node. observe properly what I'm trying to do. However, I'll later try to explain if time supports. Sorry, and one. Okay. Visited mask and okay. So this is true. Mark it as visited. So mark it as visited. Done. And oh yeah, q dot push b. Okay, so the BFS is done. BFS is done. If visited count is equal to set bits, then count plus plus return count. This should work. It is not visited mask, it's vis mask. Exponent is too large. Shift is, why is it too large? First thing, j equal to 0, j less than n, and j plus plus. Done. 2, hopefully 0. It's giving 1. It's giving 1. That's a problem. Expected output is 0. So let's look over it later. It will take a little patience to debug it. Till then, let's move to the next question. You're given an integer array nums, where nums is strictly increasing. You're also given a 2D integer array. What was it? 2D integer array queries. Yes, I should zoom in a bit. Queries of the form liri k. For each query, you should do this. Okay, consider finite. Remove. Okay, so we are looking for kth even number that is not present in a specific subarray, right? So since it's monotonic, the array is monotonic, like strictly increasing, we can apply binary search on the answer. Okay, so for a candidate even number x, the number of remaining events is what we need to find out. So remaining would be equal to total events which are less than or equal to x minus even numbers in that particular range L to R which are less than or equal to x. How can we count this? How can we count this? So can we use some sort of a range query data structure like prefix sums to count how many even numbers exists in the range of nums? And we can do this in O of 1, right? So yeah, that would be a good approach. Vector int prefix n plus 1 size. Okay, so this is a basic implementation problem. If you are able to break it down into this approach of binary search and prefix sum or anything else, maybe there are other ways to solve it too. If I read it multiple times, I can tell you a few ways, but it's not the time to do it. Okay, so this is the kind of prefix sum we use here to count stuff. This is the kind of prefix sum we use. And okay, we need a vector int answer. Let's iterate over each query. Queries until equal to q of 0 r equal to q of 1 and k equal to q of 2. Q of 2 start equal to 1 constraints. Let's take some big number. Okay, while start less than or equal to n, long way equal to start plus n minus start divided by 2 current even equal to mid modulo 2 equal to 0. If it is even, then mid, otherwise mid minus 1 would obviously be, yeah. Yeah, isn't it? Okay, so I guess we need upper bound nums dot begin plus 1, sorry, plus L nums dot begin here plus 1 plus R. Okay, This is it, right? Are we writing the right expression or not? And here we are passing int. What was the variable name? Int of minimum of long max and current even. That's a complex expression now. Num begin, it -1. So I need to count if it's in that part. Prefix of index +1. Prefix of or else it would be 0, right? Initially total events, they're not 0, wait. Current event by 2. Total events minus content sub is greater than or equal to k. Result equal to current even and end equal to mid -1, else start equal to mid +1. Did we use this variable anywhere else? No, right? Okay, so after this we can return answer. Okay, so this is supposed to be res only because answer is already a used variable. This is supposed to be res. This is supposed to be res and we are returning the answer. Is it working? 266 and it's giving you 246. It's giving you 246. Huh. 246. Why is it giving you 246? Logic seems solid. Okay. N equal to nums dot size. Prefix sum we have created. Prefix sum looks pretty, right? If it's even, there would be an increment, otherwise there would be no increment in the count. Vector int answer, iterating over the queries, L equal to Q of 0, R equal to Q of 1, K equal to Q of 2. Low equal to, yeah, same thing, start equal to 1, and this thing equal to L long max. Taken a variable result to store the answer, while start less than or equal to end, mid equal to start plus end minus start by 2, which is also right. Current even equal to mid modulo 2 equal to 0. If that's true, the current mid would be taken as the even number because it's even. Otherwise, mid minus 1 would always be even. And if current even is less than 2, if current even is less than 2, start equal to mid plus 1 and continue. And taking upper bound, nums dot begin plus L, nums dot begin plus nums dot begin plus L plus L, nums dot begin plus R plus 1, and int min of L long max current even, L long max and current even. This is also right. idx equal to distance of nums dot begin comma it minus 1. If index is greater than or equal to L, prefix of idx plus 1 minus prefix of L, otherwise 0. Total events equal to current even by 2. Total events minus count sub if it's greater than or equal to k. Result equal to current even, end equal to mid minus 1, L start equal to mid plus 1. Then we are doing answer dot pushback. Everything seems right. What's with this now? Are we implementing it in some wrong way? Are there any silly mistakes or something? Everything is so right about this. Let's move to the previous one. Now I've started feeling that 3DP is more intuitive than this. Yeah. Let me think a bit more over bit masks. Later, let's move to 3DP. Which test case is this failing? It gives 2 for this, which is right. So it fails for nums equal to 1. Edges equal to an empty list. So this is even worse. Let's move to the fourth one only. It's weird to say this, but that's all we can do at this moment. Fourth one is a bit more intuitive compared to this one. Okay, so what can we fix in this? What can we fix in this? Think of it. So find the kth number. That's somehow the question, right? Right. You're supposed to find the kth even number in the sequence some of even numbers, 2, 4, 6, something, so on. After removing any even numbers that appear in a particular L to R range, it's still a prefix sum plus binary search. So we are using prefix sum to count how many even numbers are in nums up to a certain index. Wait a minute. What are we exactly doing here? Let's run this now. 266. Oh, that's the problem. Was that a bad typo? 6 to 12 and 2 8. Hopefully accepted. Now it's time for this one. Are there any typos here too? Did I miss something? Let's restart it. Let's code from start once again. So there was supposed to be a total count, which is long total count, initially 0. As defined as z size, as defined pv push back. Okay, so what if we take it this way? What if we do a DFS here? Into int p vector in ampersand nums We need an adjacency list. And a vector int visited. That's it. And visited of start node is true. Let's implement a quick BFS even equal to okay, so if it's an even, we'll assign it 1, otherwise nums of u is equal to 1. Then we'll assign 1 to this and 0 to this. There would be an extra or 2. Making an adjacency matrix. I'm not explaining because even I'm not sure this would work or not. Because if you see, okay, let's see what would happen. I'm not very confident about this approach. But the bit mask one is not working. So we are aiming for a tree DP version. Fine. I'm unsure about the counting logic. N comma false. It's printing 39. Not even close. Let's roll back to the previous approach. Can't I go beyond this? Can we handle that failing test case somehow? Can we handle it? And I'm very close to guarding. So with this contest, maybe I can become guardian. With this adjacency list is made, let's take a int count equal to 0. Let's take the mask equal to 1. Mask less than or equal to, sorry, mask less than Initially there are no nodes in the subset, so for int I equal to 0, I less than I plus plus, if mask shift I, if it's a set bit, then sum plus equal to nums of I, and in sub plus plus, first equal to minus 1, first equal to I. Alright, and if sum modulo 2 equal to 0, if in sub equal to 1, count plus plus, is the variable name count only? Yes. Else we would do a BFS, we have the first node, visited mask equal to, this means the node is visited. Okay, this means the node is visited, we are marking it as visited. Fine. And visited count equal to 0. Initially no node is visited, while a simple BFS q.pop visited count plus plus auto percent v, maybe j of u, if mask right shift v is set, okay, if mask right shift v is set and visited mask of v is also set, then you should visit it. How to visit it? Just to or equal to q dot push v, and once you push it, get out of this if statement, get out of this loop, if visited count is equal to in sub, is the variable name in sub only? Yes, it is. And then count plus plus, return count. It's printing 2, it's printing 0. Okay, so yes, done. So that's it guys, that's it for today. We have solved all of them. Ranking is somewhere around. Should look at it. 1552. Why is it 1552 when there are only 282 all kills? There are 282 all kills. Mine is also an all kill. Yeah, I guess this is the correct ranking. Let's refresh once again. 458. Not bad. Was a good contest. So I guess it's time already. Uh, and I'm a little bit of tired, I can say, fairly. So we'll have a post-contest discussion instead of discussing it in this video. So thank you everyone. But I hope the implementation was clear. A good chunk of people might have understood why did we do what we did, like the bit masking one maybe, or why the approach shifted to 3DP, but why the 3DP failed, and once again why did we midway shift to bit masking approach handling that one particular edge case. Yeah, so that's it for today. Thank you everyone.